Okay, this is May June 21 6-1. This is S2. That's the first question. It says, let me just first open the marking scheme to this. Okay, it says accidents at two factories occur randomly independently. On average, the number of accidents per month are 3.1 at factory A. So this looks like a question from Poisson Distribution. And it says find the probability that the total number of accidents in the two factories during a 2-month period is more than 3. So these are numbers per month, and I'm talking about the total number of accidents. So total accidents per month is 3.1 plus 1.7. That gives me 4.8. And if I want to find during a 2-month period, so lambda should be 2 into 4.8. That is 9.6. The probability of more than 3 is 1 minus probability of 0 minus probability of 1 minus probability of 2 and minus probability of 3. So I'm going to write it down. 1 minus e power minus 9.6 minus 9.6 e power minus 9.6 minus e power 9.6 into 9.6 squared divided by 2 factorial and e power minus 9.6 into 9.6 cube divided by 3 factorial. I'm going to put everything on my calculator and write one final answer. I get all of these probabilities added up, give me 383. Okay, let's check if that's the correct answer. Yes, that's the correct answer. Okay, the next question, the time in minutes taken by students to complete a test has the distribution this, find the probability that the mean time taken. So this is a question from sampling and estimation. Okay, to complete a random sample 40 students in less than 12 minutes. So I'm asking you to calculate the probability of t bar less than 123 minutes. Okay, t bar is going to have the distribution 125 comma 36 divided by n. So this becomes z 123 minus 125 divided by root of 36 over 40. That gives me probability of z less than minus 2.108. So that's 5 minus 2.108. This is 1 minus 5, 2.108. Let me check if I've done this correctly so far. Okay, so 2.108 from the table. Gives me 2.108. .10 and 8.9824. 0.9824. Okay. Explain whether it was necessary to use the central limit theorem in the solution to part A. Now, since the original distribution is already normal, I don't need to use the central limit theorem. So no, it's not necessary because the population is already normal. Okay, going on to question number 3. It says the probability density function of a random variable x is symmetrical about the line x equals to 4. Okay, so let me just draw a small sketch. So what the question is telling you is that if there's x equals to 4, there's a symmetry. I don't know what it's going to look like, but let's assume that it looks like something like this. Okay, then it says that probability of x less than 5. So if I draw a line on 5, it's telling me that this entire thing is 20 over 27. Then it's asking me for probability of 3 and 5. So since there's a symmetry, what I can guess is that this area should be equal to this area. Now for this red area, what I can say is that it's 1 minus 20 over 27, which is 7 over 27. And if I want to find the probability of x between 3 and 5, what I can say is that it's 1 minus 7 over 27 minus 7 over 27. Both red areas being subtracted. That gives me 13 over 27. Let me just check if I've done my calculations correctly. Yes, that's the correct answer. Okay, then it says 100 randomly chosen adults throw a ball once. The length L meters of each throw is recorded. The results are summarized below. Calculate a 94% confidence interval for the population mean length throw by adults. So when I want to calculate the confidence interval, what I need to do is I need the value for x bar, I need the z value, I need sigma, and I don't need to divide by root n. So x bar plus z into sigma divided by root n. So computing things one by one, x bar is simple, 3820 divided by 100, which is 38.2. For sigma, I will need sigma square, which is sigma square is n over n minus 1 into s square, and s square itself is computed with a formula. So let's put in that formula. What do I get here? I get 100 over 99, and then the formula is sum of the observations squared divided by 100 minus the mean squared. Okay, putting this entire thing on a calculator. What I'm getting is 427.03. Okay, so sigma is then root of that, which is 20.665. Okay, and the z value, since it's a 94% confidence interval, what I need to read is 97% from here. So going back to my table, 97% is not at the bottom of the table, so I'm going to have to look it up in the table itself. 97 is 9699, and I can choose either 0 or either 1 or 2. So this comes out to be 1.881. It's a 1.881. So the z value is 0.881. So I get 38.2 minus 1.881 into 20.665 over root of 100 mu 38.2 plus 1.881 into 20.665 root of 100. Okay, then putting again things on a calculator. I get 37.8. I get 38.6. Seem to have done a calculation mistake somewhere. It's a small calculation mistake that I've done. This number is different and sort of creates okay, that's the correct answer. I made a calculation mistake that would have gotten me 1 mark less than the total marks. Okay, this says on average 1 in 75,000 adults has a certain genetic disorder. Use a suitable approximation. So this looks like a binomial question, but I see that p is very small. P is 1 over 75,000. So what I'm going to do is I'm going to say that I would convert this into, since n is large and p is small, I'm going to convert this into a Poisson distribution. NP, lambda is NP, which is 0.133. I want to calculate the probability of at least 1. So 1 minus probability of 0. To 5. Okay, that was simple. Then it says in a random sample of n people where n is large, the probability that no one has genetic order is more than 0.9. No one has genetic order. Okay, so I'm talking about, since n is large and p is small, I'm going to again use the idea of converting a Poisson or binomial to a Poisson. NP is basically n over 75,000. Now, in a random sample of n people where n is large, the probability that no one, so x equals to 0, is more than 0.9. So e power minus n over 75,000 is greater than 0.9. I put an ln on both sides. That gives me ln 0.9. ln e is 1 and the ln of 0.9 is okay, multiplied by 75,000 gives me minus n is greater than minus 7902. So n is less 0.0. N is less than 7902.0. So the largest possible value of n is 7902. So 902, that's the correct answer. Then question number 6. The probability density function of a random variable x is given where k is a constant. State the value of expectation of x. So yes, since it says state, the answer must be exact. Now if you can see that this is a symmetric function, so I can confidently say that if the two roots that are obvious, 0 and 6, then the midpoint is at 3 and the midpoint is also the expectation in this case. So expectation of x should be equal to 3. The line of symmetry is the expectation where the curve is symmetrical. For variance of x, I can do x square f of x minus dx minus expectation of x whole square. I integrated on the entire limit. So x squared f of x. I will need the value of k. Now, how can I find out the value of k? What I can do is I will have to go back to my basics and find out the value of k first. The question doesn't say so, but I still have to find it in order to do the working. So on this side, I'm integrating on the entire limit 0 to 6 and saying that this is equals to 1. So 6x squared divided by 2 minus x cube over 3 with limits 0 to 6 equals to 1. Okay, so k 3 times 6 squared minus 6 cube divided by 3, 0 and 0 equals to 1. What does that give me? 72, 36. So k looks like it might be 1 over 36. Let me just first verify that so that I know that I'm doing the question correctly. K is 1 over 36, yes. So x squared 1 over 36, 6x minus x squared dx minus 3 squared. The expectation is also correct, yes. Has to be integrated. So 6x cube minus x power 4. So I get 6x power 4 over 4 minus x power 5 over 5 from 0 to 6. Inserting the limits gives me this is 1 over 36 outside this. So 9/5. Yes, that's what I wanted to prove. Okay, then question number 7 says that now 2 questions are left. The masses in kilograms of large and small sacks of flour have distributions 55 in this. Some sacks is loaded into a boat. The maximum load of the flour that the boat can carry safely is 340. Find the probability that the boat can carry 3 randomly chosen large packs of flour and 6 randomly chosen. So there's a total for the distribution. So 3L plus 6S. So the mean would be 3 times 55 plus 6 times 27. That gives me 327. Variance would be 3 times 3 squared plus 6 times 2.5 squared. Okay, then it says find the probability that the boat can safely carry when it is 340 kgs, less than 340 kgs. .619. It's 5 of 1.619. .9472. I hope that's the correct answer. Yes, that's the correct answer. Then it says find the probability that the mass of a randomly chosen large sack of flour is greater than the total mass of 2 randomly chosen small packs of flour. Now this is a question about multiples, so I have to be a little careful. Again, I'm asking you what? I'm asking you to calculate the probability that one large is greater than 2 no sorry, this question is not about multiples again. Okay, is greater than the mass of 2 randomly chosen packs of small. So L minus 2S. This question is about differences. Okay, so I create a new variable called difference. So difference is normally distributed. Okay, the large one had a mass of 55 and the small one had a mean of 27, comma, three square and 2.5 square. So 3 square plus 2 into 2.5 square. It's again 2 randomly chosen small sacks rather than twice a small sack. Had it been twice, it would have been a question on multiples. So difference is greater than 0. 0.216. 0.216 gives me 32 plus 23. So this gives me 0.5855. Let's check if I got the answers correct. This one is correct, and the first one is also correct. Now the last question on this paper. At a certain large school, it was found that the proportion of students not wearing correct uniform was 0.15. Okay, P is 0.15. The school sent a letter to parents asking them to ensure that the children wear the correct uniform. The school now wishes to test whether the proportion not wearing correct uniform has been significantly reduced. It is suggested that a random sample of students in grade 12 should be used for the test. Give a reason why this would not be an appropriate sample. Because grade 12 is not the only grade. Not be the only grade. Hence the sample is biased. Okay, let's see what the marking scheme says. It says not representative of all the students, or the idea of not being representative, have different characteristics. Don't accept not random or biased without further explanation. So yeah, so I've given you further explanation. Grade 12 would not be the only grade. Okay, then it says a sample of 50 students. So n is 50 is selected, and the number not wearing correct uniforms is noted. This figure is used to carry out a test at the 5% significance level. Okay, so H naught was P is equals to 0.15, and I'm trying to test if the proportion not wearing school uniform has changed. So less than 0.15. Use a binomial distribution to find the probability of a type 1 error. You must justify your answer fully. Okay, the probability of a type 1 error is the probability of rejection. Probability of rejection. So I'm going to have to do some trial and error and test some probabilities. Although n is large but p is not small, and since it says use a binomial distribution, I have to continue using a binomial distribution. Okay, so let's do some trial and error. So what I'm going to do is I'm going to say that out of 50, let's say I was expecting 15%. So I'm going to start trying from 15%. And I'm going to try probability of x less than or equals to 7. Or I should take a smaller number actually and see where it goes. Probability of x less than or equals to 3. 1, 2, 3. I can start with any number that's going to tell me whether I need to go higher or lower, since my significance level is just 5%. Okay, so this is 50C0, 0.85 power 50, 0.15 power 0, 50C1, 0.85 power 0.85 power 49, 0.15 power 1, 50C2, 50C3. Now since I have my Casio classes calculator, I think I can do these calculations very quickly for you. I have some videos uploaded to help you use your calculator better. Please look at those. 350.5 I'm getting 0.046, which is approximately 5%. So I just need to do a bit of trial and error and see that if less than or equals to 4 gives me a better number. This is 0.112. Okay, so my rejection region is this, since closest to 5%. And since I've offered you justification in the terms of trial and error, so that is absolutely fine. This 3 was just a hunch. I could have gone above or below, that depends on what you want to do, but take a reasonable number and depends on what you want your rejection significance level to be. So check if I've done this correctly. So I've calculated less than or equals to 3, then less than or equals to 4, then I've told you this. So the probability of type 1, I should write that at the end as well. This one. Then it says, in fact, 4 students out of 50 are not wearing correct uniform. Okay, so this is 4 is my test statistic. Outside rejection region. So H naught is not rejected, which means that proportion is the same. Proportion of students not uniform is the same. Of not wearing correct uniform, same. Okay. State with the reason which of the type 1 errors may have been made. Okay. A type 1 error is made when you reject H naught. Type 2 is made when you do not reject H naught. So in this case, a type 2 error was made. Okay, that's the end of the exam.